Hello and welcome to video for section 6.5. This will be the first video of two videos. In this first video we're going to look at the law of sines and how we can use it to find sides of a triangle or angles of a triangle. In the second video we're going to look at some of the complications that could arise, and so how we have to be careful when we're using this idea of law of sines. So again, this is 6.5. This is law of sines. I will tell you, 6.5 is law of sines, 6.6 is law of cosines. These will be two of the more important sections of this book, of this semester that we deal with. So, this law of sines is a fairly simple idea, but if anything is even a little bit unclear, please be sure to take down some notes, ask it in class, because I want to make sure you guys have this down fairly good, because you're going to be using it a lot the remainder of the semester. So when do we use law of sines? Well, it's the following. Up until now, the triangles we've been dealing with and using the trig functions, trig ratios, inverse ratios, things like that, have all been right triangles. If we don't have a right angle, so if a triangle has no right angle, we can use law of sines or, as we'll see in the next section, law of cosines. But in this situation we use law of sines to find the sides and or angles. So what this means, quite simply, so if we look at this triangle here, we have no right angles. Let's call this angle A, this angle B, and the top angle C. The sides opposite this we'll label as little a, little b, and little c. So whatever angle, whatever side is opposite the angle, we'll just call it the smaller lowercase letter. The law of sines says the following. This is a cheat sheet item. In this triangle ABC, using the law of sines, we get the sine of angle A over the length of side A is equal to the sine of angle B over the length of side B, which is the same value as the sine of C over the length of side C. So pretty powerful law that we have here. If we're given a couple sides in an angle, or if we're given two sides in one angle, or two angles in one side, we can figure out the rest of the information just using this law of sines. So let's look at an example of how this would work. So let's say in this example we want to solve the following triangle. We want to find the angles and the lengths of these different sides. So we have this triangle here. The angle on the bottom left we'll call A, angle at the top B, angle on the right C. And we're given that the length of side C is 80.4 units. We're given this little angle down here is 20 degrees. Angle A is 20 and angle C is 25. So what's one of the first things we can do? Well, we know that we're going to need law of sines, or use the law of sines, and so we're going to need these different angles. So we know in a triangle, the sum of the angles is 180 degrees. So angle B, this is our little angle symbol, is 180 minus 20 minus 25. So angle B is equal to 135 degrees. Again, we're going to need this later when we start trying to figure out the length of side B. If we're going to use law of sines, we'll have to have that angle. So for now, what do we have? We have angle A, angle C, side C. So using those three pieces of information in our law of sines, we can say what? We can say the sine of angle A over the length of side A, which is over here, is equal to the sine of angle C over the length of side C. So now plugging in our values, we get the sine of 20 degrees over side A, we're trying to find out this information, is equal to the sine of C, so the sine of 25 degrees, all over our length of C, 80.4. So if we do some algebra, we move some stuff around. This tells us that the length of side A is roughly 80.4 times sine of 20 all over the sine of 25. So I'm just doing some algebra here. I'm multiplying both sides by A. That cancels out here. I multiply both sides by 80.4. That gives me what I have in the numerator. And then to get A by itself, I divide by sine of 25. So again, we're just trying to solve for A here, use some algebra to move stuff around. So that says that the length of A is approximately 65.1 units. So it could be feet, could be meters, centimeters. We're not given a unit to start, so we just leave it as units at this point. So that's for side A. We have angle B. So what are we missing now? We're missing the length of side B. So again, I'm going to use law of sines, but now I have what? I have angle A and side A, angle C and side C. So I could use either one, but which one do I want to use? So think about that for a second. I can either use angle C side C or angle A side A in order to get sine B, or the side of B, because I have sine of B over side of B is equal to one of these. And the answer is what? I want to use angle C in side C. And why is that? Well, what if I goofed up my calculations? What if I didn't put in the right decimal point, or maybe I hit cosine instead of sine on my calculator? This value would be wrong, would it not? So if I'm using a wrong value to figure out the side of B, what's going to happen? My B is also going to be wrong. So if you're given information like we are in this case, angle C, side C, use that information. Because we know that that's correct. That's what the book or the problem gave us. So this is the equation I'm going to use to find side B. So now if I plug in the information, I get sine of 135 over the length of side B is sine of angle C, which is 25, over the length of C, which is 80.4. Again, multiply both sides by B, multiply both sides by 80.4, and then divide by sine of 25, so I get that B is approximately sine of 135 times 80.4 all over sine of 25, which is approximately 134.5. So that's how we can use law of sines in order to find missing sides or missing angles of a triangle. So that ends video 1 for section 6.5. Come on back, we'll finish it up, talk about some of the possible complications we could have given the use of law of sines.